Okay. There we go. Okie dokie. So, that's ionic nomenclature. Now, there is one more part of ionic nomenclature which we're going to leave until the next exam, and that's doing ionic nomenclature with polyatomic, atomic ions. Okay, poly means more than one, right? So we're talking about more than one atom in an ion. Okay, now the polyatomic names are super weird, and you're just going to have to memorize them. There is a list in the chapter 2 and chapter 3 key terms and definitions. But for example, we have, whoops, let me try to spell it right. Phosphate, which is going to be PO4 3-. Why? Don't ask. You just gotta know, when you see phosphate, it's PO4 with a 3- charge, okay? Anytime you see an 8 or an ite at the end of something in the chemical name, that should be an indication that you're dealing with a polyatomic ion, right? And again, we're not going to do that on this exam. We're just going to pretend like it doesn't exist for now. We'll talk about it as we get into chapter 4, okay? But the way we name things is still very much the same. I'm going to show you just one example, and then we'll stop talking about it so nobody freaks out. So let's say I wanted to figure out what the chemical formula is for sodium phosphate, right? So if I want to know the chemical formula, first thing I need to do is know the ion notation for each one of these guys, right? So sodium is going to be Na+, and we said phosphate is this guy, right? So how many of each do we need to make a neutral compound?
We need 3 sodiums for 1 phosphate.
Exactly. So we're going to need 3 of these guys for every one of these guys, right? So we'll have Na3, and then you can put parentheses around this guy to indicate that it's a polyatomic ion, right? You only have to write parentheses around it if you have like a subscript out here, right? Because otherwise, if you don't have the parentheses, it looks like you're saying, let's say this was a 2, right? It would look like you have 42 oxygens, not 2 of these guys, okay? So again, not something you're going to need to know for the test coming up this week, but it's something that we're going to be getting towards, okay? And the polyatomic names and chemical formulas you will need to memorize. Just the ones that are on the key terms and definitions. So it says...
Sorry, Professor. Even if it's only 1 phosphate, when it's 1 phosphate, you don't have to put the parentheses?
Yeah, so they're optional in this case, right? So if you put it just like this, that would be fine, right?
Okay.
But I think some students find it comforting to help remember that this is a polyatomic ion, right?
Okay.
to keep it in parentheses, and I'm totally fine with that, right?
Okay.
But in terms of the convention, the way you'll see it generally, usually you won't see it with parentheses here, right? If you had something like calcium phosphate, right? Calcium would be 2+. Phosphate has its 3- still. So you would need 3 of these guys for every 2 of these guys, right? So the way you write that is calcium 3. And now you have to have the parentheses, right? Does that make sense, guys?
Yes.
Perfect. Questions about this so far, guys? Cool. So, whoops. I think this is the last thing that we need to cover. Uh-oh, we're going slow. Oh, just kidding. I'm off the map. Sorry, guys. So the last thing we want to talk about is Lewis dot. I leave these for last because I think they're the easiest. It's just a visual representation. Visual representation of valence electrons, but only main group elements do we use this for, okay? So you put the chemical symbol, and then you put the number of valence electrons around it, right? So if I'm talking about sodium, how many valence electrons do I have? 1. That would be my Lewis dot structure. If I'm talking about oxygen, how many valence electrons do I have?
6.
6, exactly. So what I'm going to do is I'm going to start off by putting 1 at each end, like these, and then the last 2 I'll pair up. It doesn't matter whether I paired them here or here or here. That's how we do it. Coolsies? Honestly, I personally do not care if you spread them all around, as long as you make sure that you're pairing them when they need to be paired, okay? So if you were to write it like this, I would be fine with that, okay? Let's do phosphorus. How many valence electrons does phosphorus have?
5.
5. Right? Pretty easy, right? And again, if you chose to write it like this, that's also fine with me. Okay? Either one of those would be acceptable to me. Okay? So this may seem like a really stupid thing to know, but when we get into making covalent compounds are all about sharing electrons. And so when we start sharing electrons, doing these Lewis dots is going to help us be able to understand how the electrons will be shared in a molecule, okay? And that's what we're going to get into in chapter 4. Does that make sense? Questions
Yes.
about that? Cool. I think, let me just do one more quick look through.
Actually, I do have one. So on this quiz or the
Yeah, but
Okay.
I mean, it's
Fine.
literally going to be like, this is kind of one of those weird questions where, because you can't draw, it's going to have to be like, which one of these pictures is correct, right? So it's as long as you know how to identify the number of valence electrons, you should be able to figure out the Lewis dot. Does that make sense?
Totally.
Yeah, it's a great question though. Beep boop beep boop. So there's some other definitions in chapter 3 that I think we're going to save for chapter 4, just because I don't think they're super duper important at this point, and I don't want to overwhelm you for this exam. So let me just take a quick look at our practice exam and make sure there's nothing that I've left out. Good. Name and ions. Cool. Cool. Okay. So the way that you're going to see some of those questions, I just want to show you the way that you'll see them on an exam for naming compounds. So ionic nomenclature. So a lot of the times what I'll do is I'll give you the ions, ion notation, and then I'll ask you for the number of cations required, the number of anions required, and then the chemical formula. Okay, so specifically, let's say I gave you, let's do these two ions, right? How many cations are you going to need for the chemical formula here? So how many of these guys? One. Does everybody see that? So in order to make our neutral ionic compound, right, we're going to need one cation, right? How many anions?
One.
One also. So that'll give me a chemical formula. Oops. RBCl, right? Mary, did I answer your question?
Yes, thank you.
Okay, cool. So that's usually the way that you'll see this. Occasionally you'll see this as one question and this as another question, right? The other way that you could see this is, instead of having ion notation here, I give you the compound name, right? Or the chemical name, right? But those are the permutations of how you'll see this on the exam, okay? Questions?
Would you include polyatomic ions for those?
No.
No. Okay.
No polyatomic ions on exam 1. Yeah.
That's very clear.
I know there's going to be plenty of other people that are going to be asking that same question. So, because the polyatomic ions require some memorization, I don't put those on the first exam, even though it's technically part of chapter 3. I don't want you guys, 3 days before an exam starting to memorize stuff, right? That's crazy pants. So, and the other thing is as you're going through and doing more and more practice with the nomenclature, as you go through and do the lab for the nomenclature, you're going to see these so many times that they'll start to stick without necessarily having to practice them. So, so I want to give you guys the time and the opportunity to do that. So that's why I'm holding off on the polyatomic ions until the exam 4. You will see those. I'm sorry, exam 2. You will see those. Sorry. Yeah, absolutely. So, any other questions? I think the only other thing I wanted to do an example of before we take off is understanding how to answer some of the periodic trend questions. So when we talk about periodic trends, we're talking about the ionization energy, the atomic radius, the electron affinity, or the metallic characteristic, right? So the way that you'll see these on the exam is you'll have a question that asks you, let's say, which one of the following has is the largest atomic size, right? So if you know that the periodic trend for atomic size is that the radii increase as you go down, right? And decrease as you go across, right? Let's say I gave you carbon, nitrogen, oxygen, and fluorine, right? Which one would be the biggest? Carbon. Does that make sense, guys? Everybody all right with me on that? I'm not going to give you anything that's really tricky, like carbon and phosphorus and selenium, right? Because when you start going diagonally, things get a little shaky, right? But it's going to be something where it's relatively easy to understand, right? So let's do another example. Let's say I'm asking about the atomic size, but now we're talking, you're given sodium, potassium, rubidium, and cesium. Which one will be the largest?
Cesium.
Cesium. Does that make sense, guys? Everybody comfortable with that? Questions? Oof. Let's see.
So going to the left increases and then going to the right decreases, right?
Yes.
Okay.
And here's your pretty picture. And your polyatomic ions. Ta-da! But mostly pretty picture, right? So when we're talking about the ionization energy, right? Ionization energy increases as you go across, right? This is the energy required to remove an electron, right? So it makes sense that as we go from metals to nonmetals, right? It's going to require more and more energy to take that extra electron off. For the ionization energy here, right? Ionization energy increases as you go up, or another way of saying that is it decreases as you go down, right? Okay.
So does it decreases because the valence electrons are farther away from the nucleus?
Exactly right. Yeah. So so the more spread out your electrons are, the farther away your valence electrons are going to be from your positively charged nucleus, and so they're held on a little bit weaker, right? Yeah, great questions. So again, understanding the trends, I think, is much more helpful than memorizing them. There is one trend that's on here that we haven't talked about yet, and that's electronegativity. Electronegativity has to do with covalent bonds, so we'll talk about that in chapter 4. Okay? So you don't need to worry about that one right now. Any other questions before I let you go? Cool. Thanks, guys, for coming and participating in the lecture. So it's not just me talking to a wall. I always feel,
Thank you.
yeah, I always feel like it's weird then